Good morning 10th standard. Let's continue with exercise 5.1. We have done second and the third question. Now let's take a look at question number 4th. Question number 4th is, which of the following are APs? If they form an AP, find the common difference D and write 3 more terms. So there are 3 things you need to do. First of all, you will check whether the given sequence is an AP or not. If it's an AP, then you need to write down what is the common difference, which is represented by small d. After that, you have to write down 3 more terms in the given sequence. Let us see how we will do this. This is the first part of this question. We have a sequence. The numbers are 2, 4, 8, 16, so on. So this is an infinite sequence. Now, just like we did question number 3, I'm going to represent these terms with A1, A2, A3, so on. So my first term will be A1, the second term will be A2, the third term will be A3, and the fourth term will be A4. So I have been given only 4 terms. I have represented them in a general way. I'm going to find out the consecutive differences now. This is the only way where I can find out whether the sequence forms an AP or not. So to find out the consecutive differences, I will be taking the terms in pairs. First with second, second with third, third with fourth. Although you can look at the sequence and tell whether it's an AP or not, but in exam you have to write this down. So this is how you will do it. The difference between the first 2 terms, A1 and A2, you have to write the difference backwards. 4 minus 2, the difference is 2. Next 2 terms, second and the third one, the difference is 4. Then the next 2 terms, the difference is 8. Now here you can see the differences are unequal. That means the sequence is not an AP. Therefore, the sequence is not an AP. Let's take a look at the next part. Second part, the sequence is 2, 5 by 2, 3, 7 by 2, and so on. So writing my terms in general way, first term is 2. The second term is 5 by 2. The third term is 3. The fourth term is 7 by 2. Now I will find out the differences between the consecutive terms. Start from the first 2. A2 minus A1. 5 by 2 minus 2. Take the LCM. The difference is 1 by 2. Take the next 2, second and third. So A3 minus A2. 3 minus 5 by 2. Again taking LCM. The difference is again 1 by 2. As for now, the things are looking good. Let's check the next pair. Third and the fourth term. So writing the difference backwards again. 7 by 2 minus 3. Taking the LCM again. The difference is 1 by 2. Now what we have? We have equal differences. So if the differences are equal, what we say, the list is an AP. So you can write down, therefore, the list or the sequence is an AP. This is the answer for the first part, where you had to find out whether the list is an AP or not. If the list is an AP, then we move on to the second part of the question. Write down the common difference. Now the list is an AP. We will write down the common difference. The common difference is this difference that is equal for the pairs, the consecutive pairs. The common difference here is 1 by 2. Now we move on to the third part of the question, where we have to write down the next 3 terms. The next 3 terms means we have the sequence till the 4th term. We need to write down 5th, 6th and the 7th term. So I will follow my definition. To obtain the next term, I will keep adding the common difference. So if I want to obtain the next term, I will add the common difference to the 4th term. Adding this common difference 1 by 2 to 4th term, I will get the 5th term. Adding this common difference 1 by 2 to the 5th term, I will get the 6th term, so on. Therefore, the next 3 terms of the APR, we already have till the 4th term. So I want to find out the 5th term. So 5th term will be written as A5. 5 will be in the subscript, and this will be obtained by adding the common difference to the previous term, 4th term plus the common difference. So the 4th term is 7 by 2. The common difference is 1 by 2. This gives me the answer as 4. Let's obtain the 6th term. This will be obtained by adding common difference to the 5th term. 5th term plus the common difference. 5th term is 4. Adding 1 by 2. Taking the LCM. This will be 9 by 2. Then we obtain the next term, 7th term. This will be obtained by 6th term and the sum with common difference. So 9 by 2 plus 1 by 2, this will be 5. You can simplify this. So this is how we are going to do. Third part is minus 1 by 2, minus 3.2, minus 5.2, minus 7.2, and so on. Again, we have an infinite sequence. Let's represent the terms in general way. So the first term is minus 1.2. The second term is minus 3.2. The third term is minus 5.2. And the fourth term is minus 7.2. Now again, I think by looking at this sequence, you have already observed that it's an AP. Let us show it by calculating the differences between the consecutive terms, and those differences will be equal. So A2 minus A1, the difference between first and the second term. Be careful when you are writing the difference between negative values. So second term minus 3.2, first term minus 1.2, and their difference. So this will be minus 3.2 plus 1.2, and the difference comes out to be minus 2. Next, difference between second and the third term. So the third term minus 5.2, the second term minus 3.2, and their difference. Minus 5.2, opening the bracket. Again, the difference will be minus 2. Let's take the difference between third and the fourth term. Fourth term is minus 7.2. The third term is minus 5.2, and we need their difference. So we will put a subtraction sign. Solving. The difference is again minus 2. So we have equal differences. Therefore, the sequence is an AP. And if the sequence is an AP, then we have to write down the common difference. You can write the common difference D is minus 2. And now we have to find out the next 3 terms. So the next 3 terms are we have to obtain 5th term because we have the sequence till the 4th term. So we need to find out 5th, 6th, and 7th term. So 5th term will be obtained by adding the common difference to 4th term. The 4th term was minus 7.2. Add the common difference, which is minus 2. So minus 7.2 minus 2, this will be minus 9.2. 6th term. Take the 5th term, add the common difference. The 5th term is minus 9.2. The common difference is minus 2. Adding minus 9.2 minus 2 is minus 11.2. And then for the 7th term, 6th term plus the common difference. So 6th term is minus 11.2 plus the common difference is minus 2. So minus 11.2 minus 2. This will be minus 13.2. Do the 4th part yourself. I'll be doing with you 5th part now. 5th part, the sequence is 3 plus square root of 2, 3 plus 2 times the square root of 2, 3 plus 3 times the square root of 2. Again, we have been given 4 terms in the sequence. So the first term a1 will be 3. The second term a2 will be 3 plus root 2. Then a3, the third term, 3 plus 2 times root 2. And then the 4th term will be 3 plus 3 times root 2. We will find out the difference between consecutive terms. a2 minus a1, taking the first two. I'm using brackets here because my terms are in binomial form. Second term is 3 plus root 2, subtracting the first term. Take your time, don't rush. So this gets cancelled, the difference is root 2. Let's take second and third term. a3 minus a2, again I'm going to use brackets because I'm writing difference. So the third term is 3 plus 2 root 2, third term minus the second term. Opening the brackets, three gets cancelled, 2 under root 2 minus under root 2. So this will be under the root 2. As for now, the difference is equal. Let's take the last pair, third and the fourth term. Again, I'm using brackets. 3 plus 3 under root 2, 3 plus 2 under root 2. Open the brackets. This 3 gets cancelled. 3 under root 2 minus 2 under root 2. The difference is under root 2. Now, from here we observe that we have equal differences. So we can write down that the sequence is an AP and the common difference D is square root of 2. Now we need to find out the next 3 terms. The next 3 terms, fifth term, fourth term plus the common difference. The fourth term is 3 plus 3 root 2 plus the common difference is root 2. 3 plus 3 root 2 plus root 2. So this will be 3 plus, these are like terms, this becomes 4 square root of 2. Sixth term will be obtained by adding common difference to the fifth term. So 3 plus 4 under root 2, the answer of the fifth term, plus the common difference. From here the answer will be 3 plus 5 times under root 2. Then the next term, seventh term, sixth term plus the common difference. Sixth term we have obtained as 3 plus 5 root 2 plus the common difference. So this will be 3 plus 6 times under root 2. Do the next 5 parts yourself. I am taking up 11th part now. In 11th part, the sequence is given as a square, a cube, a raised to the power 4, so on. Now by looking at this, you can tell that this is not an AP, but we have to show our work. Now I have to take these terms in the general way as a1, a2, a3, a4, and normally I use lowercase a. Because a has already been used, I am going to use capital A this time. So the first term I'm writing as capital A1. This is A. The second term is A square. The third term is a cube. The fourth term is a raised to the power 4. If you want, you can use the small a as well. It doesn't matter. Just to distinguish my terms from the general representation. I will be looking at the difference between consecutive terms. Start by the first two, a2 minus a1. So this will be a square minus a. So from here I can take a common. The difference will be this. This is like factorization. Then take the next two, second and the third one. This is a cube minus a square. From here a square will be common and in the brackets I will have a minus 1. Taking third and the fourth term, a raised to the power 4 minus a raised to the power 3. From here a cube will be common, in the brackets again I have a minus 1. So if we look at these answers, the differences between the consecutive terms, these are all unequal. Although one factor matches, but if we look at the whole answer, the term outside the bracket is different. So that means these are unequal differences. So what you will write down, that the sequence here is not an AP. Twelfth part, we have square root of 2, square root of 8, square root of 18, square root of 32 and so on. If you look at this sequence at a glance, you might think that this is not an AP, but before you answer, let's work it out. Remember, you have to show your work, and until then you cannot give your decision. Second thing, whenever we have irrational numbers, we want to express them in the simplest form. So what I want you to do is, I want to simplify these. If we have a composite number under the root, we use prime factorization to simplify. So under the root 8 can be written as square root of 2 into 2 into 2. This forms a pair. So this will be out of the root and this stays inside the root. So 8 can be written as 2 under the root 2. This is what I'm going to do for the remaining two terms. And then I'm going to see whether my sequence is an AP or not. So root 2 as such, because it's prime number, I cannot factorize further. Square root of 8, as you can see here, can be written as twice the square root of 2. Simplifying square root of 18, you will see that this comes out to be 3 times the square root of 2. Factorizing 32 and simplifying square root of 32, this will be 4 times the square root of 2. Now I will look at the difference between consecutive terms. A1 square root of 2, A2 twice the square root of 2, A3 3 times the square root of 2, A4 is 4 times the square root of 2. Now it looks different from the list given, and I think now you can see earlier the list did not look like an AP, but after simplification you can easily tell that this forms an AP. Again, we have to show our work before we give the answer. So let's look at the difference between consecutive terms. Taking the first two, 2 times square root of 2 minus square root of 2. This will be root 2. Third minus the second one. 3 times the square root of 2 minus 2 times the square root of 2. This again is square root of 2. Fourth minus the third one. 4 square root of 2 minus 3 square root of 2. The answer is again root 2. So we have equal differences. And if we have equal differences, we say that the list or the sequence is an AP. After this, we have to write down the common difference. The common difference D is square root of 2, and then we find the next 3 terms. the next three terms. A5, this will be A4 plus common difference. A4 is 4 under root 2, add the common difference. Answer is 5 times square root of 2. Find the sixth term. Fifth term plus the common difference. Fifth term is 5 times square root of 2. Adding the common difference. The answer is 6 times square root of 2. Then we need to find out the seventh term. Sixth term plus the common difference. 6 under root 2 plus under root 2 equals to 7 times under root 2. Now this is the 13th part. It looks similar to the previous part. We have square root of 3, square root of 6, square root of 9, square root of 12, the first 4 terms. And before we check whether the sequence is an AP or not, I'm going to simplify. So simplifying the way I did in the previous part, I'll obtain my sequence as this. So square root of 3, square root of 3, 6 on prime factorization does not form any pairs. So it remains square root of 6. Square root of 9 is 3. Square root of 12 can be simplified and you will obtain the answer as 2 times the square root of 3. Now we look at the difference between consecutive terms. The first term is square root of 3. The second term is square root of 6. The third term is 3. And the fourth term is 2 times the square root of 3. Now you can see this is not an AP, but we have to show our work. Difference between first 2 terms, square root of 6 minus square root of 3. Now you cannot subtract these under the roots. Don't write down root 3 as your answer. If you write square root of 3, that will be incorrect. So what you can do here is you can factorize and then write down the difference. So this can be written as square root of 2 multiplied by square root of 3. Under root 6 can be written as under root 2 into under root 3. Under root 3 as such. From here, root 3 is common. And in the brackets, you'll be left with root 2 minus 1. Let's look at the difference between second and the third term. 3 minus square root of 6. Again, I'm going to break these down. This can be written as square root of 3 into square root of 3 minus. This is square root of 3 multiplied by square root of 2. From here, square root of 3 is common. And in the brackets, I'm left with square root of 3 minus square root of 2. Now at this step, you can tell that the differences are unequal. You can give the answer right here. You don't need to check the last pair. Unequal differences. Therefore, the sequence is not an AP. I want you to do 14th and 15th part yourself. Remember, before you check or answer, simplify. Simplify the exponents and then find the consecutive differences. And looking at those differences, you will answer whether your sequence is an AP or not.